Okay, so what we're going to do is we're going to make an attempt to work on some geometry review. I'm having to use two computers to try to make this work. Hello, there I am, and there I am over here. Two computers, two different angles. Okay, whatever. The deal is I'm going to use this computer here to record everything, host the meeting, and I'm going to use this computer here to do the work on. Okay, hopefully this works. I'm going to share my screen. Okay, awesome. So this is the review for the test for geometry, which we will be taking on Tuesday, September 8th. And it's basically the unit one, just the basics of geometry. That's what we're going to be working on. Okay. All right. Number one thing we need to do, first problem, is we need to explain the difference between postulates and conjectures. So these two words, postulates, then a conjecture. Okay, postulates, also called axioms, but let's just worry about the word postulates, are statements which can't be proven. They require no proof because you can't prove them even if you wanted to prove them. They just kind of are. You take them like on faith. It's a foundation that you base your whole system of logic on. So a postulate can't be proven. We can't prove it, so we don't even try. So postulates can't be proven. So I'm going to write that. Postulates require no proof, or we could say can't be proven. Okay. Postulates can't be proven. Conjectures require proof. Yes, it's an educated guess. It's kind of like a hypothesis. And you prove it or disprove it. Conjectures just even true. Or true. So what a conjecture would be based off something like that. 3 numbers, 3, 5, and 7. What's the next number? A conjecture could be that the next number would be 9. Based off of the odd numbers greater than 1. So it could be, if that's what somebody was looking for, but it might take that proof. Maybe is the next number. There wouldn't be enough information there actually to know what would be the next in the pattern, because it could be, a list of odd prime numbers and go to 11. Okay. That's a conjecture. All right, so postulates. When two lines intersect, they form a point. Two lines intersect at a point. They intersect at a point. Remember, a point is just a location in space. It's just a location in space, has no size, has no dimension. It's a spot. Line, there's a line for any 2 points. Right, 2 points. We got 2 points. What's required to form a line? Define a line. And always going to be always going to be only one line that goes through those 2 points. Okay, another postulate here. When 2 planes intersect, they form a line. The intersection between 2 planes form a line. Let's see here. You can see, let's see, right here above me. Right there, right here. That's the intersection between my ceiling and the wall behind me, and that intersection is linear. If I can fall back here to be a plane and the ceiling line, the intersection between the wall and ceiling is a line. Okay. 3 non-collinear points, that's 3 points that don't lie on the same line. A plane. Just like there is a line that goes through any 2 points, there is one plane that goes through any 3 non-collinear points too. One plane that'll go through those 3 non-linear points. Okay. All right, so postulates, maybe I'll even write that in here. They can't be proven. They were proved. See if I can write that a little better. There we go. Okay, lines intersect 1 point. Two point in second. Intersect form a line. 3 non-collinear determine a plane. Okay, using postulates about lines. Yeah, I got pictures of it. Through any two, there is exactly one line. Those 2 points. Through any 3 non-collinear, there is exactly one plane containing them. So there's only going to be one plane containing 3 points right there. If 2 points lie in a plane, the lies on the plane too. Let's just kind of self-explanatory. If I had 2 points table, I had 2 points also lie on the tabletop. Okay, I have 2 lines intersect in exactly 1 point. 2 lines are only going to intersect. They're either going to intersect or they're not going to intersect. If they intersect at 1 point. If they don't intersect, well, they're going to be parallel or in geometry lines. We're going to learn about that soon. Okay, the 2 planes set in exactly 1 line. So plane, consider this to be a plane right here. This to be another plane. They intersect. It forms a line. Also, just like we have between the intersection between the wall and the ceiling, and it's linear. It forms a line. Okay. All right. Collinear points. Collinear is 3 on the same line. Could be more than 3 also. We have to say at least 3 because we know there's going to be a line that goes with 2 points. So collinear points are 3 or more points that lie. So I've got a lot of options here. One option I have is to say point A and a line. So with that, A and B. B. But I've also got here's N and D. And I also have M and N. I only have this one set of 3 points. But I will all of these to show you all the possibilities. Okay, next I want to find an array opposite of ray NC. Ray NC passes through point C. Also in the opposite direction. Okay, ray that contains the same endpoint N, goes through D forever. That's the only ray that is opposite of N. So ray D. Okay, now I want to name a set of non-collinear points. So I'm going to just pick 3 points that are the same. And 2 of them can be on the same line. A, M, and L. A have C, M, and L. Any 3 points that don't lie. So choose points I choose. Just C, N, L. C, N, and L. Okay, I want to name the line. There's AB, line AB right here. Intersection. And it intersects right here at this point. Point A and NN. Okay, so you identify collinear points, and remember, you list 3 of them or more. 3 points that lie on the same line is a collinear point. Be able to name a ray that's opposite to a given. Remember, it has to start at the same time. It's going to look kind of the same. In C, the ray that's opposite started in. I just got to find the other. Name is non-collinear. And once again, you got 3 or more points, but just use 3 points. Or a line in an array, a segment in an array. Be able to find that. Remember that an intersection is always just going to be a point. Where the phone are true or false. It says A and B are collinear. I've got A and B. All of them do not form or not say that. It's false. Because all 3 of them are not the same line. Okay. It says that ray AM and ray AB are the same. Both rays start on A. It's actually true. These rays are the same. Remember, the same point that is used to name the ray is a point that the ray is going to go through. That line. So today, like a ray gun. Think of it like a laser. It starts today. Here's like the gun, the ray gun, right? This direction, and then it's going to blast right through. This same ray that blasts through B. It starts at A. That right there is true. First letter signifies the point where it's the second letter, whether remember, these go on forever and they go that direction. Okay, now I've got it starts at D, shoots or keeps going forever this direction. And it's saying Well, N is the one like this and goes from CN starts here and goes that direction. Now, both of these are actually part of the same layer, but they are not the same rate. That is not true. That is false. Okay. C N I don't know what they're trying to say. They're trying to line N and line and D are the same. These would be through any 2 points or this side. And we just name it by any 2 points. C, D, and C, D. A lot of names I call this in. If there were any other points up there that were listed, I could name them. This is all the same line. I think that's big. Line CN and line ND are the same line. Maybe I'm going to write that down here. Are the same line. That's true. Yeah, you know, human name tells you may have a different name. My kids call me Dad. Color. I was in first class. Well, that's call me that. She got other names for you. D. Yeah, I talk about those. The origin. We're going to talk about segmented data. Point C is, it says, first of all, that point A is located at the origin. So I'll list this. I'm gonna label these. So point A, that's A. So point B is the mid segment AC. So this right here could be C. That's 32. Because the midpoint of segment AC. So between A and C. If C is at 30, A is at 0. So I've got a total length of 32. 32. Half of 32 is. So I can put B right about here. Halfway. No, B right there. Okay. B is the point. A. Okay. So this right 16 units. A is 16 units. Okay, half would be 8. So that is going to be point D. All right. Let's do from here to here. From A to 8. From D to B is 8. From B to C is going to be 16. Okay, so now I've got to find B to the distance between A. D to B is half of 16. So I'm going to find out that B here, AB is 16, and BB is 8, so it's 16. Maybe that out. AB is from here to here, which is a total of 16. And then I've got the thing from B, which is 8. I'm fine. Just miss a algebraically AC 2 units in length. So minus AD minus AD. All right. I'm going to draw the segment PQ at endpoints P. There's one here. 2, 4. That's a 4 is right here. I want to find PQ. So what if I could draw well, we'll see how it goes. Well, let me do this. It's pretty. Seeing what's going on. Okay, that's about as good as I got. Now we've got our Pythagorean theorem. So what I can do is this. Make a little try. Let's take this length and this length. All right, I'm going to label those. Let me find how many is it. Now, my counts. I've got 3, 4. That's 4 units. And then from here, 1, 3, 4, 5. A little bit of diagram. I've got 4 squared plus 5 squared is going to be this distance right here. Squared. So 4 squared. And I'll take the square root of that. And that's going to be my distance, the length between those. So that's going to be the square root of 16 plus 25 equals 41. Okay, now, so we got that. Now, what I could have done is I could just go into a calculator. Scientific calculator, scientific calculator. Demos.com scientific. And I'm just going to do the square root of, and I could do plus square. Plus 5. So my answer is exactly the square root of 41, but I'm approximately 6.4. That's the best I could do. Now it doesn't tell me the you know, how much to round it off. So I don't know exactly where to round it off. Oh, I've got to find the midpoint. Okay, so here we know that's a length of 4. So I'm going to go 2 units to the right point and 2 units to the left. So my midpoint, I'm going to put it on there. I'm going to label it. Points right here, and that's going to be at 0. Okay, this is 5. Okay, so I'm going to go 2.5 point to that low point. And that puts me at a, because from here that's -1, go 1, 2, that puts me at 1. So that's 0, 1. That will do on the right here. The midpoint is at 0, 1, 5. All right. And represents 1 mile. 3 branches of bank are located at 8. So I better start labeling these things. That's A. B is at 2, 3. I see 4, negative 4, and -1. This is A. This is B. And this one is C. Okay, an employee drives from branch A to B. So I'm just going to drive this distance here. And then he gets drive halfway to B. Getting stuck in traffic. Now there's 10 of a mile, so it's hard around. We're going to go halfway between C. I'm going to draw my second B to C. And we're going to go half that distance. Okay, so let's find this distance right here. So I'm going to go up 2, and then I've got to go over 1, 2, 3, 5. So that's 2 here. That's 5 right here. So we're going to do Pythagorean theorem and get that. Find this length. 2 squared plus 5 squared. Find the square. Find the square root of that. So I'm going to say AB. Square root of 2 squared plus 5. And I can see that this one is from B to C. There's 2 units right there. Yeah, it's 2. So the halfway point would be 1 unit over 2. So really here. 1, 2. So what I do is then I'm going to say, I'll find the square root of 1 squared plus 2 squared. Now the total distance is going to be the sum of 2. Okay, this is of B to C. So my total is I'm going to add those 2. And then I'm going to get to the near this plus this. So I'm going to go into scientific calculator. And I'm going to have square root of, what was it we were looking at? 2 plus 5 squared. 2 squared. Whoop. get in there. 2 squared plus 5 squared plus half the distance from B to C. That's going to be the square root of 1 squared plus 2 squared. That gives me 7.62, 7.6 miles. How long did she drive? Well, since the employee may have driven before getting, we're going to say approximately 2.6 miles. Almost the cheat sheet type thing. Remember, if I a hypothesis would be if I'm in Alamo, the conclusion is I'm in Texas, then I'm in Texas. The converse is conclusion and hypothesis. So an example of the converse would be if I'm not the Alamo, the converse of the original would be the original is if I'm at the Alamo, then I'm in Texas. The converse, if I'm in Texas, then I'm at the Alamo. And remember, converse statement may not be true, may not have the same truth value as the original. Have the same truth value as the original conditional statement, but no, it's not hypothesis. At the Alamo, I'm at the Alamo. My conclusion was I'm in Texas. So it would be at the Alamo, and I am in Texas. And it doesn't turn out true, even though the original conditional inverse does not always have the value as the original conditional statement. Sometimes it does. As it turns out, converse and inverse are always going to have value. If the converse statement is true, the inverse will be true. If the converse switch the hypothesis and conclusion, and so the result was if I'm at the Alamo, then I'm positive is if I'm at the Alamo, which is also true. Contrapositive will always be the same as the conditional statement. If it is true, the contrapositive will also be true. Okay, here's some we got to know if integers are negative, then their sum is always negative. So if integers are negative, then their sum is always negative. So if I have 2 integers, my sum is going to be negative, and that is true. The converse, though, let's see. If 2 integers is all negative, then the 2 integers. Okay, remember, that statement is true. It could be true most times, but if you can find one counter, that statement is false. So, we could have the sum of 5 and 4. That has a sum, so all that a sum of -1. But that are not negative, so false is false. It's a false statement. Here's a counter example. All right, integers are not negative, but it just means that one of them has to be not negative. Okay, so This one is and this one's not, so it's not negative. Just one of them is. Then there's some is not always. That's false because here we have, and I could have, some which if I had a it's true sometimes. It's false just once. It's always false. And the contrast. If the sum of integers is not always negative, it's negative. More difficult than math ones, but okay. Right, so that's your attention to this. You get stuck at any point. Uh, you're taking your tasting, and no one's going to stop you from watching this. Okay? So good luck on the test. That's all I got. And test.